Hello YouTube viewers, welcome to my show Future Friday. In today's episode, we're gonna continue our substation saga and we're gonna look at mobile substation. So let's dive right into it. Now, before we go deeper into it, you have to understand why there is a need for mobile substation. Now, there are aspects of emergency. Let's say earthquake happens, hurricane happens, and your substation is destroyed. It takes time, but people need power. People need, like hospital needs electricity for its making sure its patient survives. Like electricity is essential. We cannot take a risk with it. So, in case of emergency, we really need it. In case of scaling, let's say you have a substation that was built for 100 megawatt. Let's say they are buying a transformer, but it takes time, and during that time and you need extra 50 megawatt, you can add a mobile substation. And it also adds flexibility. Let's say for some scenario, a big major event is going to happen somewhere, but it's only going to be temporary. Let's say like a big cricket match or things of that nature, but it is temporary. You know for a fact that power will be drawn in here temporarily and then it's going to be removed. So in those sort of scenario, mobile substation will help. And it also aspect of cost, because at the end of the day, substation equipments are big, bulky and heavy. So many times you can have a scenario where your transformer itself, especially in very big cases, would be very big, and the consequence of that would be, even though transformer would be, let's say $50 million or $100 million, the transport cost itself could reach that much, simply because if you have a very large vehicle, you have to make sure you never go under basically a flyover, bridges or things of that nature. You need to rent big bulky trucks which are very expensive to rent, and they are rented per hour. So in those sort of scenario, it also helps us save cost. And on top of that, because it's a mobile unit, it's built, everything like is inbuilt already into it, it saves time. So let's say you have a transformer fire, you call all the people up, it's like, hey, I need one mobile substation, boom, everything done. It saves time, it saves cost, allows for flexibility, allows for scaling of the equipment, and in case of emergency, it's it's a very crucial must-have situation. So what the heck it is, this mobile substation? Now exactly what it sounds, it's basically substation on wheels. So you will have your transformer, you're gonna have your switching gear, basically isolator and circuit breakers, and everything would be in one complete package. So all you need is just one truck. Now these trucks are generally rated for normal use. They are not, rarely they are built in such a way that you need special clearance for that. So that's the whole idea of it. It's something a normal 18-wheeler truck engine can easily handle. It's very simple, elegant. It's just one big unit. So how does this work? Like if we need giant substation, and if you have checked my video about it, like if there is a lot of consideration put into building a substation, then how can we do all that in a mobile system? Now you have to understand, it's not something that you can plug in your home. Even though let's say you have a high voltage power line going to your home, through your home, as in rooftop, you still cannot have a, hey, bring me a mobile substation, I'm gonna connect and I'm gonna directly run my system. That's not how it works. You still have to place it, basically this mobile substation, you have to place it in a grid. Basically the grid would most likely place for that would be substation. So you actually park it into substation, and on top of that, because the inherent nature of this, it is not very good for grounding. Basically any short circuit happens here will energize the whole vehicle. That is very dangerous for people around it. So the first thing you do once you have parked it in, let's say, your substation where you're doing repairs or you're replacing it, you're gonna connect this to the grounding grid. You check my last video for more details. And on top of that, you're gonna connect the high voltage side to high voltage bus, and then you're gonna connect the low voltage to low voltage bus. So that's all you are doing. Basically it's a transformer on wheels, if you want to simplify it. You still need substation, you still need a grounding grid. That is the most critical aspect. Without that grounding grid, it's not gonna do anything. So that's how it works. So even though you can see something that is built there as a permanent installation, the main thing they are doing is just making sure that it is grounded properly. So that's how it works. Like you bring it into a substation and you do your maintenance. Basically, let's say you are in a scenario where you have two transformers. One of them is damaged, and during that time you have to turn over like all 100% of the electrical load will go through one transformer. It will also get damaged if you do that for long enough. Now you will try to do that first, 5-6 minutes of maintenance, see what happens, what is what, and you find out no, it's gonna take 1 week to fix it. Then you're gonna call these people up. It's like, okay, bring me a substation, of course appropriate rating. The rating must match, and then you're gonna connect it. During that time it's carrying the load, your perfect transformer is working, your mobile transformer is working, the damaged transformer can be replaced. And these puppies are designed to work for a very long time. Now they cannot keep running 24/7 into 365 into 5 to 6 years. They're only there for running for a few months. at a time. Now generally they are only needed for a week or something like that. So that's how it works. Now what enables this sort of technology is basically insulator. Now if you are familiar with insulator, you know porcelain insulator, while they are very good, they are time tested, they are fragile, and if you have this constantly moving, they're gonna shatter under their own weight. So this is not acceptable. Like, of course you can still do it, and older mobile substation did try to do that, but problem was they had to spend a lot of time. Like once they reached to the site, they had to test every single porcelain insulator. So you can understand it, it's not a very optimum situation. So we figured out how to build basically what we call composite insulator, something like this, which is far more stronger than porcelain, far more resilient, as in like it can handle bending, it can handle temperature fluctuations, and even a gunshot. Basically if you shoot it this with a gun, this shatters. This does not. I have provided the video down below where people are testing it out on the circuit breaker. They pressurize the circuit breaker with SF6 gas, which is generally commonly used with 6 bar. They shot it, normal bullet, nothing 50 caliber or something like that, normal bullet. It basically made it explode, and when they shoot in, it just basically punctured it. That happened. So that is very crucial. You want something that is resilient. So insulator is the first line. On top of that, if you are familiar with high voltage systems, you must understand that if you check my last episode, was that circuit breaker needs intelligence. Circuit breaker needs sensor. Now in normal old school substation, you have what we call current transformer, you have voltage transformer. These puppies are big, these puppies are oil filled, these are very expensive, space consuming equipment. It's not a compact situation, and if oil goes low on any of these things, they explode. So for you can understand, people don't want this in a moving vehicle. So we are switching this to optical system, basically where we have optical current and voltage sensor. They are much smaller and they are accurate. Actually they are 10 times better than this. Then you might be asking why the heck we don't use it everywhere. Well, we are starting to. We are slowly replacing this puppy. So this also allows us this sort of technology, because if you have tried to build a, let's say, very powerful, as in like 50-60 megawatt mobile substation, basically the half of the equipment space would be just used by these things. So because now we can build what we call optical systems, they are very compact. Heck, many of them are so compact that literally bolt it on top of a transformer itself. You don't even need extra space for that. So sensor allows us basically to miniaturize the substation. So what we can expect in the future? Now you have to understand, these systems are still very early stages. Nowadays people are relying on them more and more, especially for maintenance work. This is like a godsend for maintenance work, because if you like, it happens like you have two big transformers and you're designed in such a way that another one transformer can handle the load for a short while. You can't have a scenario where the another transformer can handle the load for, let's say, weeks or months. It can barely handle it for, let's say, hours at the end. And if you don't do that, it will overheat, reduce the efficiency at first, and over a while, let's say you did it for 2 weeks, it's gonna get damaged. So to protect in those sort of scenarios, we really rely on these puppies. Either you disconnect the substation or you bring on these. So right now the biggest problem with this, even though these are mobile and all that, the turnaround time, basically you come in and you install things, they still take a large amount of time. I'm still talking in terms of 1 or 2 days it takes. So we're gonna improve that turnaround. Right now the biggest unit you can buy, as in like, let's say you are running a substation and you are like, hey, I need a mobile substation, the biggest power factor that you can get is not power factor won't be correct, but basically the rating you can get is roughly 50 to 60 megawatt, or let's say 50 MVA or things of that nature. You can't go much bigger than that. So to solve that, Siemens have come across with the idea of building a basically mobile substation. Only difference would be, instead of having 3-phase transformer, they're gonna have single-phase transformer. Benefit, you can get 3 times the power. So, and it also makes it cheaper because you only have one circuit breaker, one isolator. So it does save money on other aspect, which reduces the weight, because you have to understand, these mobile substation also has to handle the road regulation, because if you are building something, let's say, that's supposed to be put on a normal truck, it must wait under a certain criteria. If you exceed the criteria, you have to pay extra taxes for that. People don't like paying taxes. So you have to make sure that if weight savings can be had, and while you are increasing the capability of your system, it's awesome. So in Siemens case, they have built a mobile substation that is upwards of 200 megawatt. So what they have is like basically three clones of these, where each system is only one phase. You have 3 of them, and then you have a completely independent control and command center. So we're gonna make this more modular, more scalable. I can never see them becoming as big as, like, let's say 800 megawatt or something like that. However, for small states and small substation, this is a godsend. You can easily do repair, you can easily, heck, in many places they put it there and just run on it completely. It can be easily done for 10 to 20 megawatts. If you're pushing it to 200-300 megawatts, then it becomes an issue. Then it's not designed to do it continuously. And of course, this also allows us to slowly, effectively replace our old aging infrastructure without shutting it down. That is crucial. We can't have a scenario where it's like, yeah, I'm upgrading a substation, so I'm gonna shut down the electricity. Yeah, that's not allowed. You can literally have a scenario where a substation is feeding power to a hospital, and like you will get sued. Like, and that's the best case scenario, you are getting sued. Like a worst case scenario, somebody like who died because of your power cut could like, you know, whose relative can do serious damage to you. So this allows us very cheap upgrade path. It's like you're gonna put 2-3 of them and, like, you know, take the loads of, remove the old aging equipments and then replace it with new one. So there is a quite bright future in mobile substations. So this was my presentation on mobile substation. I hope you liked it or learned from it. In that case, please leave a like, click the ad shown in this video, that will directly help me. And if you didn't like it, don't worry about it. You can press dislike button twice to show me your extra disappointment, and please leave a comment because I reply to all of them, and subscribe, press the bell icon if you're free, and as always, thanks for watching.